basics. Hopefully by the end, you should have a grasp of things you want to do and the way to work through it. As you might have just seen the notice there, this is being recorded, so you'll have a link to the Zoom afterwards, so you can kind of go back and come through it. Trish is very helpfully here. So Trish is a researcher in the same group as me. So she's a biomedical researcher. She's going to be monitoring the chat, answering any questions that you have. We've got a breakout room if there's anything that you need more kind of help with. But generally, I think we're going to try and just stay together here, and we're going to kind of talk through things as we go. In terms of the way we're going to set this out, so this is a two-part course. So we've got 3 hours today, and then 3 hours on Monday morning. So same times, 9:30 to 12:30. We'll try and have a break, probably like a short 5-minute break, about 10:30, and then maybe another one, kind of another hour after that, just to kind of stretch your legs, get a coffee and things. If there's any, if you're needing a break or anything, don't worry about it. Just either disappear off or put a notice in the chat. That's fine. That's not a problem. Yeah, generally, if there's any questions throughout, just shout up. Either just unmute yourself and interrupt me, or check a question in the chat, and Trish will bring it up if it's needed. So if you go to the chat, I'm going to put all the links to the course materials. So we're basically just going to be following on with everything on this web page here. So hopefully everyone can see the chat and can see that link. Shout up if you have any problem loading it. But we're just going to be working through that. I'm going to be live coding as we go. So I'll share my screen now, and we can go from there. In fact, before I share my screen, I think it'd be good to kind of do some introductions, just so we know what we're here. So if we could just get everyone's name, what you're recording, and we can start learning some MATLAB. So the first thing to see is, can everyone see my screen? Brilliant. I'm seeing some nods. You've got a thumbs up ability in Zoom near the bottom. Reactions, I think it is. So that's, yeah, I can see some coming up now. So that's going to be super useful. Obviously, if you don't want your cameras on, that's completely fine. It's good to have the kind of the thumbs up or notes in the chat, just so I know that people are still there and are following, to make sure that you're kind of understanding and everything's going on. Cool. So this is the MATLAB window. This is how it looks. I'll kind of talk it through in a little bit. But first, let's take a look at the guide. So I'm going to put this in the chat one more time, the links to the course materials. So this guide was basically going to talk through all these sections in the schedule. And the way it's going to work is I'm just going to talk it through. You can follow along with it if you want, but don't worry if you'd rather just listen. And I'm going to live code all the examples, and we're going to talk through all the details as we go. So it's going to be a real kind of collaborative way. If you've got MATLAB up with you, you can code along with me, and then any problems or any errors that you see, just shout up either in the chat or on voice, and we'll talk them through. So prerequisites. So the only thing that you're going to really need for this lesson is to have MATLAB open and installed. Nobody's shouted up to say that they haven't got it installed yet. So if you don't, put in the chat, and we'll look at that. But hopefully everyone's got it installed, because that'll be much easier. And it says you need to know how to start up MATLAB and access the command window. We'll talk through the command window in a second, but as long as you can have it up and running and you don't have any problems with that, that would be great. And as Trish has just said in the chat, so feel free to send her a message, either on the group or just privately to her. If you want to ask a question. If you don't want to ask it in front of everyone, that's completely fine. But probably best to send the messages to Trish, because while I'm talking, it's harder for me to monitor the chat. So before talking through what MATLAB looks like, we're going to click on this Setup tab. And we're going to see here, number one, download this MATLAB novice information.zip and move the file to your desktop. So what we can do is just right-click this. So I'm on Mac. So if you're on Windows or Linux, your right-click menu will look slightly different. And you can just click download or download as, might be save or save as, or you can just click on the link and it'll download it. So I'm going to download this, and I'm going to move it into my folder, my software carpentry folder, and I'm just going to save it. And you'll see that it's kind of appeared here in my MATLAB. And then I can right-click it and click extract, because it's a zip file. So You might be on, if you're on Mac, you can just double click a zip file and it'll extract. If you're on Windows, you normally have to right click and click extract or extract here or something like that. But if you work that through and any problems, again, you can just shout in the chat and we'll go from there. So this folder is just going to contain, if we go into it, it contains some data and it contains a load of files. And these are kind of files that we're going to look at as we go on. But you don't really need to worry about that for now. We're going to start with something a little more easing into MATLAB. So first, we're going to start with this working with variables section. And the aim here is just to kind of get familiar with MATLAB, get familiar with what we're looking at on the screen here. What are all these little different windows, these different options, and how can we use MATLAB essentially as a calculator? So how can we can use it to just do some basic arithmetic. So your main MATLAB window here is called the command window. This is kind of the main thing where things get done. You type commands in here, so I can just type some stuff in, and then you can hit enter, and it will execute your command. We've got some other things here. So we have our current folder. So this tells us where we are, or if you see up here, it tells you what folder we're in. So the current folder is really important because MATLAB looks for commands to run either within the MATLAB kind of installation itself, or you might have some custom things in here that it needs to look for. So if we try and load up something that's in data and we're not in the data folder, that's going to be an issue. But if we double click and go into the data folder, we could load up some of these files. And we'll talk more about that in a second. We have this thing called a workspace. You can see it's empty at the moment. So this says basically all the things that MATLAB knows that it has in its memory. This is a bit like storing something in your calculator. And we have something at the bottom called command history. So you might not see this. I've set this up. So all the commands that I type into here will come up. So if I type hello, you'll see it comes up at the bottom here. So if you want to just have a quick rehash of the commands that I've entered, you can look here, and from the bottom up, the bottom will be the most recent, and then the history will go up as we go. So that's the basic idea. These two arrows are the MATLAB prompt. So everything we type in here and then hit enter, that's gonna execute a command. And we can use this to do lots of different things. So for example, we can say 5 plus 5, and we can hit enter, and that's going to give an answer of 10. So MATLAB can just be used as a giant calculator, but we can also save things as a value. So we could say weight in kilograms. We could say this is equal to 55. Then that's going to say weight in kilograms is equal to 55. And you see in my workspace, if I just drag it over, you see we've got this thing here that says weight kilograms, and it's got a value of 55. So that means MATLAB stored this variable. So this is called a variable. The variable name is called weight in kilograms, and it's got a value of 55. So if I just type in now weight kilograms and press enter, you say it says 55. So you can do this with lots of things. It doesn't have to be weight. It can be anything. This could be any name I want, and this can be any value I want. And it doesn't just have to be a number. It could be a set of numbers. It could be a string, so a word or a set of characters. It could be a matrix. It could be lots of things. So by the end of this course, you should be able to see all the different sorts of data types that you can use and that you can save in different types of variables. And then you can do stuff with them as well. So once we have these variables, we can either print it to the screen like we've done by just typing it in weight in kilograms and hitting enter, or we can use a MATLAB function called disp. So disp stands for display, and MATLAB functions, they work by having a set of parentheses, and then you put an argument in. So the thing that you want to display, you put in. So weight in kilograms, and then you hit enter, and it's just going to display. It won't say the weight kilograms equals, because we just want to display the value. So there's different ways of kind of getting things to come up. By default, things will show after we type them in. If we want to suppress that, we can use something called the semicolon. So if I want to say weight in kilograms is equal to 55, and I don't want it to print out to the screen, maybe because I just want to keep things nice and neat, I can just put a semicolon after it, and you'll see it's done that. It's saved it in here. So it's still done all the same things. It's just not shown me what it's done. So that semicolon is kind of suppressing the output and keeping everything nice and tidy. So that's great. We can save single values. But obviously the benefit of a computer is that you can do lots of things with lots of values. You know, a computer has memory, it can hold lots and lots of things. We can do basic things in our heads. We don't need computers to do that. So the way that we store multiple values in the same variable is using an array, and we create an array using square brackets. So we're going to create an array called A for array, and we can say equals, and then we use these square brackets to say what the values we want, and we separate them by commas. So we say an array could be 1, 2, 3. You see each value is separated by a comma. The last value, we don't need a comma after it, so I can delete that, and then we close it with a square bracket, and then we can press enter to display it, and you see A equals 1, 2, 3, or we could have put a semicolon on the end, and that would have not displayed it to the screen. So we use commas to separate columns, and in the same way, you can use semicolons to separate rows. So if we took an array called B, and we wanted it to be a column vector, so we could do 1, semicolon 2, semicolon 3, and we finish it again, and you see this is now in a single column with rows saying 1, 2, 3, whereas before we had 3 columns but 1 row. And you don't have to just enter new things each time. You can build them up using other things. So say we've got our row vector A, and we want to have a second row in it that says 4, 5, 6. So say an array C, we want to start with A, so that's our first row. We use the semicolon to say we're going on to the next row, and then we can say 4, 5, 6, separated by commas, and then closing that, and that's just going to build it up in that iterative fashion. And we could do this again with C and add another row, and we can do this again and again and again. So that's just a way of kind of building up arrays. And you see on the right-hand side, all these things that we've saved, all these things that we've told MATLAB to think about. So we've got our row vector A, we've got our row vector B, our array C, and we've still got weight in kilograms. So MATLAB now knows all of these things. We can ask it to recall it. So we could just say A, and we can ask it to do things with it. So we could like multiply it by 2. So we could do A times 2, and then that would multiply each element in the array by 2. But one thing to think about when we're thinking about arrays is that arrays have to be in MATLAB all of the same type. So I kind of briefly mentioned type at the start. So type is like a number or a string or a character. So A would be a character, maybe a word like software would be a string, because it would be a string of many characters, one after the other. And then obviously a number is a number. But we can't mix and match these in a single array. So we can't have an array, let's say array D. So we're going to make it an array. So we use the square brackets. We're going to say maybe the first entry is the letter A. The second entry is the letter B. The third entry is our, let's say the number 3. That's not going to work. You see, it's not done what we think it should have done. It's done something weird. And the reason it's done that is because we've tried to put in something that's a mixture of strings and numbers, so it doesn't quite know what to do with it. So we need to be a bit careful with that. But we can also convert between different types. So say we have our row vector A, which we can see at the top, which is 1, 2, 3, and we want to add maybe a letter to the end. Maybe we want to add the letter A just to the end of that array. We can't do that naturally because obviously these are numbers and we want to add a string. But what we can do is change A. We can convert A from a number to a string. So we can use a MATLAB function that's num2string, num2string, str, and we can call it in the same way that we called the display function. So we have some parentheses, and then we put our argument in A, and you see that that's changed it to a string. So it looks exactly the same as we had before, except we've got these speech marks either side. So speech marks indicate that this is a string now. So that's converted A from an array of numbers into a string. Everyone seems to be making sense. I'm not seeing any questions come up, so that sounds good. And we can do lots of things to these things. So we can do, like I said, we can times things by 2. We can add things to it. We could do any sorts of math that you necessarily want to it. So we can use this to say convert a value. So we've got our weight in kilograms. We've got that as 55 kilograms. Well, what would our weight in pounds be? Well, we know that 1 kilogram is 2.2 pounds. So times 2.2 with our weight in kilograms. Hit enter, and you see it's given our weight in pounds as 121. And if we wanted to make this look nicer, maybe when we're actually analyzing stuff, we want to give a nice output that prints to the screen that people can understand, we can use this display function. So we put our parentheses in, and then we could make an array, a string array, that says, so we use these speech marks for strings. So we can say weight in pounds, and then we can combine it. So we're using the comma because we're making a row. And we can use this num to string, because obviously we can't combine a string and a number. So num to string, weight in pounds. And then if we hit enter, you see it's kind of combined that into one string, weight in pounds, 121. So this is quite a complex command. What we've done here, we've kind of chained a load of things together. So let's have a bit of a more detailed look. So the display function has a single argument. So we know that display function takes an argument. We have these parentheses that are at the beginning, at the end. So everything inside here that I've highlighted, that's the argument of the display function. But just because it's one argument doesn't mean that it can only display one thing. So what we've actually asked it to display is a single array, but that single array had 2 components. It had a string that was weight in pounds, and it had a string that was the weight, the actual weight that we'd saved, but we'd converted into a string. So you can chain things together quite nicely, but what we're doing, even though there's many things in here, it's still only outputting one thing, one array. If we'd tried to do it without that, we might have run into issue. I think this is a good time to really point out probably the most helpful MATLAB function that exists, and that's the help command. So if you're ever unsure about how to use something, or how many arguments it has, what order the arguments go in, we can use this help command, and you type in help and then the name of the function that you want to look at. So in this case, we're using the display function, and you hit enter, and then it searches, and we can scroll up, and it tells you all the information. So disp, this is the function names. What it does is it displays an array. So disp, and this says it takes one argument, that's x. So it displays the array x without printing the array name or any additional description information. So if you remember, when we just typed in A, it printed the name. It said the name was equal to, and then it printed the array. But when we do disp A, it just prints the array. There's no other additional information. And that's what it says here. Displays array x without printing the array name. And then it gives you some other links to things that you might be interested in, like there's this num to string function. That's the one that we've looked at. So if we click on that, it will find us the help for num to string, and it will give us all the information about that function as well. So if you're ever unsure about how to use any of these MATLAB functions, exactly which order the arguments go in, or if you get an error, you can always do help and then the function name, and then that will give you this really nice explanations. It's probably, I use the help function more times than anything else. I use the help function multiple times a day, all the time when I'm coding. It's incredibly useful. And probably one of the best things about MATLAB, actually. I think a lot of other coding languages, because of their complexity, their help files and their documentation tends to be a lot more involved, tend to require a lot more knowledge. I don't know if so those of you that have actually tried to do some coding before and maybe tried to search how to do something, often the things you get back take as much effort to understand as the problem itself. Whereas MATLAB, because of the way it's written, it's got professionally made documentation, it tends to be really, really well laid out, and it's a really good advantage of MATLAB, and it's really helpful to use. Cool. So once we've saved all these values, such as our weight in kilograms, they're not fixed forever. They're not going to change on their own, but they will change if we want them to change. So say Our weight in kilograms increased because we've been in lockdown and potentially eating too much and not getting out enough. So our weight in kilogram is now 57.5. And you'll see here on the right-hand side, the weight in kilogram, it's no longer 55, it's gone up to 57.5. So you can use this to change values. Maybe you want to keep adding things. Maybe your variable is a count and you want to add 1 to your count every time something happens. You can keep changing these and keep going off, but everything else has stayed the same. So you see our weight in pounds, even though we've changed our weight in kilograms, we haven't assigned our weight in pounds to anything. So our weight in pounds is still 121. So if we want to update that, we'd still need to go through and update it and see what's going on. Sorry, all my Zoom windows just jumped all around the place there a second. Yeah, so if we want to update weight in pounds, we'd have to go back and say 2.2 times weight in kilograms. Or we can use a super helpful MATLAB function, which is just the up arrow. So I can type weight in pounds, I can press the up arrow, and because I've already used this command before, it will pre-fill all those things, and then I can just hit enter. And you see it's now updated. So it's now 126.5. And you see in this workspace on the right-hand side, it's now updated to that same value, 126.5. So that's a very important thing to remember, is that things don't change unless you've instructed them to change, or you've set up some rule where they will learn to automatically change. So just because you update one variable, if you're working with multiple variables that are all linked, you need to change them all or set up a way where they can all be changed. So we've talked about the workspace, so we can see the workspace in here. Another way to see the workspace is to use the who command. So in MATLAB, if we type in who and press enter, it will tell you all the variables that we've got saved. So you see we've got A, we've got the answer, we've got B, we've got C, we've got D. All these things that we can see in the workplace, we can see it here. And maybe we don't want one of these anymore because maybe we've decided we've used it. We don't want it to get confused with anything else. We can use the clear command. So clear just clears the memory, wipes the memory of what's going on. So we can say clear the weight in pounds. We hit enter. You'll see it's disappeared from the workspace. It's no longer here. We can say who again. It's gone from here. And if we try and access it by calling it in here, we get an error. So error functions in MATLAB are red, and it says unrecognized function or variable, and then it says the name of the thing that it hasn't recognized, in this case, weight in pounds. So whenever you get an error, and you will get lots of errors in MATLAB, that's the way any programming languages work. Don't be worried about errors or feel like you've done something wrong. Errors are there very much to help you and help you understand what's going on. So this is saying unrecognized function or variable, so it doesn't know what you've asked it to do, and this is where the problem is, and that's because we've deleted this variable with the clear command. And we can also, if we want to get rid of everything, we can use the clear all command, and that's just going to clear all our variables. You see our workspace is now clean, and we're starting again. So that's a good thing to be aware of when you're starting MATLAB, is that you probably almost all the time want to start with a clean workspace. You don't want to remember variables that you've maybe saved before in case that you run into errors because you've saved something, you've forgotten that you've saved it, and they can be quite hard errors to find. So the clear functions are very useful things to have. Generally, when you shut down MATLAB, unless you've specified otherwise, it will just clear the workspace for you. So when you load it back up, you're loading again a clean workspace. Okay, so we've got a little task in the work now, so I'll just bring it up here. Here we go. So predicting variable names. So the task is to predict what variables refer to what values after each statement. So we've got mass equals 47.5, age equals 122, mass equals mass times 2, age equals age times 20. So answers in the chat. What's the value of mass after we put this into the workspace? And if you can't see the chat, by the way, there's a button at the bottom of Zoom that just says chat. Cool. We've got one set of answers from Andre. Let's see how everyone else is doing. Remember, if you've got MATLAB open, you don't need to be doing this by hand. You can just type it in and get the answer out of MATLAB. This is not school maths. You know, using the calculator is not, it's not cheating. It's very much what we're trying to do. Cool. Medi's got an answer as well. We'll just give a minute or so for other people to kind of type it through and see how they get on. Remember, if there's any problems or you don't understand what you're being asked or anything like that, just either shout up or send a message to me or Trish, and we can talk it through. In the absence of any feedback, I'll just presume that everyone understands and keep plowing on. So do shout if you don't, because if we don't get the understanding here now, as it kind of gets more complicated, it'll get harder. So it's very much about getting everyone up together. Brilliant, we've got some more answers coming in. Also, do shout if you feel like I'm going too slow or too fast or whatever. If you can't understand anything that I'm saying, just shout up, and I'm always happy to re-go over it or let Trish explain it in a clearer way. So that's always an option. Cool. So we've got lots of answers of 95 and 102. And if you've got this page up, you'll notice that you can click the solution and it will tell you. So mass equals originally 47.5 and originally 122. And then you can do it and you can read the answer there, or we could just do it in MATLAB. We can say mass equals 47.5. Remember, you can always delete things if you make mistakes, like I've just done. Age equals 122. If we want to keep things nice and neat, remember we can use the semicolon, and then we can say mass equals mass times 2. And we can say age equals age minus 20. I've used the semicolons there that aren't in the documentation, but that's just to suppress output and keep it nice and neat. And then we can use this display function to say display mass, that's 95, as everyone has said, and display age, that's 102. And all we could have cheated and looked at the workspace over here rather than using the display functions. So there's lots of ways we can kind of get to the same information. So that's kind of like the basic idea of how to use MATLAB, how to kind of get through, introduce a variable, maybe do some stuff to that variable and kind of work it through. In general, you're going to be doing stuff that isn't just typing in the command window. You're going to be creating your own functions like this display function. You're going to be writing scripts that do lots and lots of commands, but do them in a way that's repeatable. So you can run the same script, it'll do all the same commands again in the same order, and you'll get the same result. This is the real benefit to doing something quantitative, is that you get the same answer with the same thing that you put in. You know you're always doing the same thing. So by the end of tomorrow, we'll have gone through how to write your own functions, how to write your own scripts, and you'll all be MATLAB whizzes, and it'll be great. So there's lots of things you can do. I mean, MATLAB is a very amenable language to doing lots of bad practice things. The nice thing about MATLAB is that it's very easy. We don't have to worry about lots of things that we would do with more complicated programming languages. But because of that, I think we almost have to be more aware of good practice and how to do things well. So a real key thing with the things that we've been thinking about is your variable names. So you see we've called things age and mass. Those are good variable names. Or we said weight in kilograms, weight in pounds. Those were good variable names because we could look at them and we know exactly what they were and what they were containing. The arrays that we called A, B, C, D, those are bad variable names. So that doesn't tell us anything about what's in the data, about what it is and what it's doing. You see lots of people just say X equals 55 for your weight in kilograms. But if you come back to that later on, you don't know what X is. So thinking about the way you present your code, the way you save your variable names is very important. And really is going to help you coming back to things and being able to reuse your code and being able to work with others as well. If you take someone else's code and it's full of X equals 55, Y equals 2.2 times 55, that's not going to help you understand what's going on. If you come to a code and you have weight in kilograms equals 55, weight in pounds equals 2.2 times 55, then you're going to immediately be able to read the code a lot better and understand it. You can think of it like learning any language. If you can read it, if you can understand it easily, that's good. If you're reading a scientific paper and you can understand it easily, that's good. If it's full of confusing names and confusing jargon, that's bad, and that's going to hinder your understanding in your work. And the same thing happens with how you organize your folders and how you organize all your codes. So if we go back to our MATLAB novice information directory, so this is where we downloaded that zip folder and unzipped it. You see, this is our project. It's got a name. This is where we're going to keep all our code for this workshop. So it's all self-contained. We know where it is. If we have any documentation or maybe text files that we want associated with our code, we can put them in a doc folder. So if we right-click in the current folder, we can go to New, and we can click Folder, and we can call this Doc. So in this folder, we could put maybe all the literature that we have about what's going on. We could put any information manuals. Maybe we downloaded a MATLAB guide that told us how to do something that was really crucial to what we were doing. I'd put all that in there. Obviously, we've already got our data folder, and our data folder has all our data in. So that's really nice and neat. And then we could have something like, if we say New Folder, so remember we go to the current folder, we right click on the mouse, we go New, we go Folder. We could have a results folder, and everything goes in there. So those will have all our results. Maybe any figures that we plot, we could save in there. And if we right click, we go to New, we go to Folder. Oh, sorry. So if you accidentally click one of the other things, and so here I've created a file, you can just right click and click Delete. So we right click, we go New, we go Folder. So source or source, but the convention is to call it SRC. So this will contain all the code that we want for our project. So this is kind of like the general way that you'd set up a code. I wouldn't worry about it too much, but the principle is exactly having a nice organized structure that you can use for every project. Everything's self-contained. You don't want to have files all over the place, like in different folders. You don't want to have 100 files called Untitled 1, Untitled 2, Untitled 3, because when you come back to it, again, it's going to be very confusing. You're not going to know what each thing's do. I mean, everyone will have had this when they've written a document or they're doing something and you kind of write your version, and then you'll write version 1 and then version 2, and then you'll think you're finished, so you'll write version final. And then you'll go back and make another change. So you'll write version final _1, and version final, and then everything gets very messy and you kind of lose where everything is. So really you need to have a nice clear structure that is really going to help your code. And that might not seem like it's coding, it might not seem like it's computing, but really that is the fundamental process. If you do things simply and you do things clearly and in a repeatable way so that they're readable, so that you know where the structure is, your life is just going to be so much easier. So you see currently we're in this overarching folder. This is where all our different folders are that have all our different things in. We can see this up here where it says exactly where we are. So we're in the MATLAB Novice Information folder. If I wanted to use the GUI, I could click this little button here to the left, and that would bring up a window that looks like this. In Windows, it'll look slightly differently, but you can navigate to the folder that you want to be in this way, if that's easier for you. Or you can just click Open. If we want to see what's in it, we can either look on the left-hand side and see what's in the folder, or we can use the MATLAB code ls, the list, and that's going to show all the folders that are in here. So we have the data folder, the doc folder, the results folder, and the source folder. And remember, if you're not sure how to do it, you don't use man, you use help. So you say help, ls, and then that gives you everything that's on. So ls, list folder contents, and then it tells you a bit more about it and shows you some other things that you might want to look at as well. So if there's one thing that you learn in this whole course, it should be the help function. Never forget about the help function. It's the most useful thing in MATLAB. So we've already, someone mentioned in the introduction about loading data and it being a really thing they wanted to get out. Well, this is a real fundamental part of computing, right? Of any sort of analysis, of research. We end up with data. That data could be anything. It could be, you know, gene expression levels in biosciences. It could be a list of matrices in maths. It could be a load of survey responses in some social science. It could be anything, but the general idea is that we often have some data, we want to load that data, and we want to do something to it. So that's going to be what we want to do. And one of the functions that we're going to use to do that is going to be the read matrix function. So again, we can type help and we can type in read matrix. And that's going to give us something that looks quite complicated because there's lots of different things in it. But if we scroll all the way up to the top, it's going to say read matrix, create a matrix. So a matrix is just an array in MATLAB that has rows and columns, and it's going to create one by reading from a file. And then it tells us how to do it. So A equals read matrix, and then a file name creates an array by reading from a file. So what I'm going to do is I'm just going to go to this current folder. I'm going to click this little arrow and click minimize, and then same on the workspace. I'm going to click this arrow and click minimize, just so you can see. So you can see that there are little tabs here. You don't have to do this, but you might find it helpful to just kind of concentrate on what's going on. So this tells us how to use it. So it's a function. It's called read matrix. It can take one input. It's called file name, and that's great. So if we scroll back down, what we can do, we can move into our data folder. So we can type cd current directory data and hit enter, and you'll see up the top that we've moved into our data folder. You could have done that by double clicking on the folder in the current folder window, or by clicking this button up here and navigating via the GUI. So you see we've gone into the data folder. And then if we want to see what the files are, we can use this ls command that we've already used. And you see there's 12 files. This is all our data files for what we've got. So these are patient data files, or fake patient data files. So each file corresponds to a different set of data. And the data is going to have some interesting information in. So I think we'll come back to exactly what's in the data in a second. But for now, we just want to load one of these files and get the information into MATLAB, get the data into MATLAB so that we can start working with it. So remembering that we need to use sensible variable names, we're going to say patient data, and let's take the first one. So we're going to call it 01. So I've separated my words with underscores. So you see my underscores here and here. You don't have to do that. There are different ways that you can do it, but I recommend that this is quite a nice way of doing it. Keeps everything nice and clean, makes everything sensible. A couple of things to mention that with MATLAB, case matters. So if I call something capital P, that's different to calling something lower p. And you can't start a variable name with a number. So it can have a number in it, but it can't start with a number. So we're going to say patient data 01 equals, and then we're going to use this read matrix command. We're going to open our brackets, close our brackets. So it takes one argument, and that argument was the file name. So if we scroll back up just to double check, scroll back up, we can say A equals read matrix, and then the file name. A file name is a string, so we put in our speech marks. And then we're going to take the first one, so inflammation01.csv. And then we're going to hit enter. It's going to take some time. It's going to read that. And you see it's printed a load of stuff into our command window. Again, if we wanted to suppress that, we can, so I just pressed up there to go back to my previous command. You can use a semicolon, and you can hit enter, and it's done exactly the same thing. It feels like nothing's happened because it hasn't done anything in the command window, but it's done all the same things. And we can check that by using that who command, and you see we've now got patient data 01 as one of our variables. So now we've loaded our data, we probably want to find out some things about it. So this might not be data that we had, it might be data that a collaborator has sent us over and wants us to analyze. So we might not know exactly what's in it. So a useful command is the size command. So we can say size. We use our parentheses because it's a function. Patient, if I spell it right, data 01. And you see that's given us a size that's 60 and then 40. So this says that there are 60 rows and 40 columns in our data. So that looks kind of right when we look at this big number, this big array. We've got loads of numbers here. So we've actually got 60 rows, 60 different rows and 40 columns. So this is called an array, as we've already said. It's a multi-dimensional array, so it has 2 dimensions. It's got rows and columns. But MATLAB stores all its data, doesn't matter what it is, in the form of multi-dimensional arrays. So a single number, let's say a equals 1. In fact, let's use a sensible variable there and call it number instead of a. Number equals 1. If we do size of number, then this is got 1 row and 1 column. That makes sense. So vectors are 2-dimensionals, number are 2-dimensionals, matrices are 2-dimensional, so they have rows and columns. But you can also go further than that. You can have like as many dimensions as you want, and then we'll show you how to access them as we go along. So tables, matrices, these are all big arrays with multiple numbers of dimensions. Single numbers are just exactly the same. They're just an array. They've just got 1 row and 1 column. And remember that we can't store different data types in the same array. So we can't use both numbers and characters in the same array. It has to be all of the same type. There are different ways that you can do that. So MATLAB has something called a cell array. So we can say help cell array. And that says it only supports searching for 1 topic. That's because I've put 2 things here. So I can say help cell, and that's going to give us some information about the cell array that we can think about, but don't really worry about for that. So this is basically a big array of individual arrays. So each one of those arrays can only have 1 data type. And if we want to know what data type we have, we can use the class function. So we can say class patient data 01 because that's what we called our variable, and this is a double. So a double is basically a type of number. You don't need to worry too much about that, but it's not saying it's a string. If we say word equals word, so you see I've used the speech marks as a string, and we do class of word, that's char. So each individual thing is a character, so that means that it's a string. And there are lots of other different types. So we can have doubles. You might have heard of things called floats, which are floating point numbers. A double is a double precision floating point number. So that just means it has more accuracy in storing the number. And then there's chars, which are basically characters. Okay, so that's the end of lesson 1. So basically what we've gone through is it's the introduction to MATLAB, what the different windows look like. So the command window, the workspace, your current folder. We've talked about variable names. We've talked about how to organize your code so you're in a sensible sort of way. We've shown that MATLAB stores data in arrays. It stores all its data in arrays, even if they're just a 1-by-1 array or a multi-dimensional array. And then we used this read matrix function that was super easy, super helpful to actually read some of our data into MATLAB and create this matrix that had 60 rows and 40 columns. Cool. Is there any questions about any of the things that we've gone over so far? Is anyone feeling like they need a break or like the pace is too fast for them? Sorry, I'm looking down at my screen because I've got you down at the bottom of my screen below my MATLAB. No, okay, I'm taking everyone's silence as indications you want me to just plow on through, but do shout up if there's anything else you want to go to. So let's think more about arrays then. So I think we'll do this section and we'll have a little 5-minute break because I'm definitely feeling like it's time for my caffeine top up and needing a coffee. So we're going to think about this array that we've loaded in, which we've called patient data row 1. And we're going to think about, well, what if we want to access a certain part of it or a certain part of any array and maybe do some stuff to that. So when we try and access a part of an array, like maybe we want to access maybe the first row, or we want to access the first column, or maybe just a single entry, what we're talking about is something called indexing. So indexing refers to the way that MATLAB or a programming language kind of builds up an array and thinks about where each element exists in relation to that array. So we're going to start by creating an array, a matrix we'll call M for matrix. And we're going to use a MATLAB function that's called magic. So this creates a magic array where all the rows and all the columns add up to the same thing. So this is just a fun little maths thing. You don't need to worry about where that comes from. So we're just using M as an example here. So you see we've got all these different arrays. And maybe we want to just access this one value. Maybe we're particularly interested in how to get to this value and maybe do something with it. So this is an array. It's an 8x8 array, so it means it has 8 rows and 8 columns. MATLAB starts indexing from the top left and counts all the way down in rows and then counts all the way across in columns, and it starts in 1. So this would be row 1, row 2, row 3, 4, 5, 6, 7, 8. And this would be column 1, column 2, column 3, column 4, 5, 6, 7, 8. Some other programming languages might start at 0, 0 in the top left and count down like that. But MATLAB starts with a 1. So MATLAB's slightly more conceptually easy to think about from that point of view. So we just start at 1 and we count along. So if we wanted to get to this value here, we are in the 1, 2, 3, 4, 5th row and the 1, 2, 3, 4, 5, 6th column. So we want to access something in M. We can use our parentheses to say we want some part of M, and we want the 5th row, we're always row first, and then we want the 6th column. And if we hit enter, that's going to give us our 38 there that we were after. So indices in MATLAB are always presented rows first, then columns. If you had one of these multi-dimensional arrays that we were talking about, you could have a 3rd index or a 4th index or a 5th index, and you just keep chaining these along with commas separating each one as we go. But maybe we're not interested in just picking out a single value. Actually, what we're interested in is the whole row. So this whole row here, we want to know, can we get access to all those values? Maybe this whole row corresponds to a single patient or a set of values, a set of times for something. You know, maybe it has some interest to us. How would we access that whole row instead of just going, you know, we could build up an array where we build up the fifth row, first column, 5th row, 2nd column, 5th row, 3rd column, but that's going to really take us a long time. Or we can use a really useful command, which is colon. So we can say we want the 5th row, but we want everything, all the columns, and then we close it, and that gives us our entire row. And we can do the same the other way around. So if we do 5, colon, that gives us an entire row. If we want the entire column, maybe the 5th column, we could do colon, 5, and that would give us a whole column. So everything in the first dimension, and then just the fifth in the second dimension. And you see that gives us our column that corresponds to this column here. And we can also do this to select multiple rows. So maybe instead of just choosing, so I'm scrolling up, instead of just choosing the fifth row, maybe we want the top of the matrix. So if we go back to our matrix M, maybe we want to access everything in the first 4 rows, say. So we can say M, remember we index rows first. So we want the first row, we want the second row, we want the third row, we want the fourth row. So we can say 1 to 4. So the colon says go from 1 to 4 in increments of 1. And then we want every single column, because we want that whole batch. So we can use the colon command to say every single column. We hit enter, and that gives us the top of our matrix. So really, this colon for the columns is just a short way of saying, so I pressed up again to get to my history. So we start at 1 and go all the way to the end. We can use this end keyword that just says go all the way to the end of our matrix. Or we know it's an 8 by 8 matrix, so we can just say 1 to 8, and that's going to give us exactly the same output. Or we can remember that you can just use a colon, and we can use that kind of shortcut there to just use the colon and go through. And of course, we can do the same for columns. Maybe we want to take the last 3 columns. So let's take every single row. So we'll use the colon command there. And let's say we want to take the last 3 columns. So column number 6, and then we want to go all the way to the end. We can do that, and that's just going to take that. So what we're calling here, what we're doing here is slicing the matrix. So what we've got here is called the slice of a matrix. So imagine taking a knife, cutting down one section of the matrix all the way. So we've got this colon here, so we're taking all the rows and we're slicing down, and that's giving us our matrix slice, which just has 3 columns in. And maybe we want to do some different subsections. So maybe if we scroll back, or maybe if I just type M in and we have a look at our matrix M again, maybe we just want to take this section here, and we want to take 3 rows. So it's not going to let me highlight it very easily, but maybe if I show you the image here. So we've got our matrix. This is our 8 by 8 matrix, and we want to just select this section here, or we can just combine the ideas that we've used. So we can say we want the 4th row to the 6th row, and we want the 5th column to the 7th column. And we close our parentheses, and that just gives us our little subsection here. So we can just chain these commands together to access whichever part that we want to get at whichever bit that we need. We can also do things in a slightly more complicated way. So maybe we don't want to go 4, 5, and 6. So this colon here is essentially saying by 1. So from 4 by 1 to 6. Maybe we want to take every other one, so just 4 and 6. We can say 4 by 2 to 6. So this is just going to give us 4. It's going to add 2. It gives us 6. So we should only get the first line here and the last line here. And that's exactly what it's done. That could have been a 3. We could say we want 4 by 3 to 6. Well, that's only going to give us 1 because we start at 4. We add 3 to it. That takes us to 7. 7's bigger than 6. So we stop. That's exactly how it works. And we can chain all these ideas through as much as we like. And maybe we want to select something that looks like a checkerboard. So in the notes, you have this little pattern here. So we're taking, in the rows, we're taking the first row, we're skipping 2, taking the 4th row, we're skipping 2, taking the 7th row. So 1 by 3 all the way to the end. And we're starting for the columns. We don't want the first column, but we want the 2nd, the 4th, the 6th, and the 8th. So we're going to start, and we start at 2, and we want to skip every 2, and then go all the way to the end. So to do that, we can say, well, we wanted to start at the first row, we wanted to go every 3 rows and go all the way to the end. And we want to start at the 2nd column, we want to go every 2, and we want to go all the way to the end. And that's going to give us just that checkerboard pattern and condense it all into our new matrix. That's just a 3 by 4 matrix. So rows first, 3, 4 columns. Okay, so we now have another little task for you to work on. So we've said that the subsection of array is called a slice. So we can just slice out some part of it. It doesn't have to be all the way along. It can just be start part. So Andre's saying having indices starting with 1 and not 0 is confusing. I think this is quite a common thing when you move between programming languages. So I code regularly in MATLAB, in Python, in C++, and in some other things. And it's always hard to remember exactly what these commands mean. So for example, in Python, you'd start at 0. So if you did 0 to 2, in MATLAB, that's going to give you 0, 1, 2. In Python, it would say start at 0 and then go up to 1 before 2. So it would just give you 0 and 1. So these ideas that we're talking about are all very similar across programming languages, but they all have these subtle changes that can be really frustrating when you're trying to switch between them. But once you kind of get the basic ideas, kind of moving towards them will work. I'd say it's potentially easier going from Python to MATLAB, because if you try and access the 0th array in our matrix M, so let's try it. Let's say M of 0, 0. So in Python, this would give you your first element, your top left in your array. In MATLAB, it's going to give you an error. So index in position 1, so this is position 1, is invalid. Array indices must be positive integers or logical values. So that's saying that what we've put in here is wrong, and that it needs to be positive, so greater than 0. So we can put in a 1 here, and then it's going to give us another error, and it says index in position 2 is invalid because we've got 0 here. So it's a lot easier to kind of notice our mistakes, and then we can get to 1, 1. If you're in a different programming language where you start at 0 and you accidentally start at 1, what you're going to do is you're going to have a successful code in that it loads stuff, but you're going to be losing everything in your 0th position. So it's just something to be aware of, that there are differences between programming languages. Okay, so this task then, a subsection of array is called a slice. We've mainly been working on numbers, so numeric arrays or numeric matrices, but we can do the same for character strings. So remember, we've got these speech marks that refer to strings, and we can create a string called element, and then we can use our display function to display what we call a slice, so 1 to 3 and 4 to 6. And if we do this, this gives us our outputs. So the first 3 characters is oxy, so the first 3 characters of element, and the last 3 are gen. So there's some questions here. Can you work out what's the value of element 4 to end? What's the value of element 1 by 2 to end? What's the value of element 2 by end to -1? We've talked about this colon operator that MATLAB allows to index a whole dimension with. So it can also do some weird things. So what's the difference between element and element with this colon operator? What's the size of element and the size of element with the colon operator? And then with your magic matrix M, so remember we can type M equals magic 8. So it's in here. I'll show you, I'll just scroll up right the way at the top. We said M equals magic 8. So if you type that in, you'll get your own matrix M. So in the task, it says, what happens when you use that single colon operator on this matrix M? So see if you can work out what's happening when we're using the single colon operator for slicing. So have a work through that. Any questions or problems, just shout in the chat. And when you're done, either stick your thumbs up or put some answers or some thoughts in the chat and see how we go. And once you're finished and you're happy and you understand, we'll have a break. So it's now just coming up to 1:45. So we'll have a break until, let's say, 10:47, when I'll come back and answer any questions about this task. Can you hear me now?
Yeah.
I've been talking at you the whole time, trying to find out if people are back, and you haven't been able to hear me. So that's my fault. Cool. That's not a problem. Yeah, if everyone's back, give me a thumbs up. So I've seen Mehdi and Kieran are back. Andre, I see you back on camera. That's great. Everyone else back? Cool. So how are we getting on with the tasks? Anyone's got any thoughts? Anyone have any problems? So no one's saying they have any problems. So
sorry, please, could you at least show us again how to import the data, please? Sorry.
Of course, yeah. So no, it's not a problem at all. I'm always happy to go back over things. So if we scroll back up, it's not in this one, is it? So if do you have the link to this? Let me put the link back in the chat. So anything that I'm always happy to go back over everything. It's not a problem. But all the information that I have gone through is also on here, so it's helpful to look back. So on the working with variables slide, we go down towards the bottom. So it's this read matrix command. So patient data equals read matrix, and then the name of your file.
So what is it exactly asking? When you write it that way, like, could you explain it to me how MATLAB is seeing it? Yeah,
so MATLAB is saying, so if we think on the right hand side, so MATLAB is saying that you're calling a function read matrix. Okay. So this is your function name. We have the parentheses, so everything inside here is your argument. Read matrix takes one argument, and that's the file name. So it has to be in strings. And here it's saying, look in the data folder for this file called inflammation01.csv.
And then get me something called patient data. Is that what it's asking?
Yeah, and then what it's saying is it's going to do this thing, and then everything that it outputs from here, it's going to save as what we've called patient data. So we could call that anything, and it would just save it as there. It wouldn't change what it's doing. It would just change how we refer to it.
Sure. Can you show me how it shows on your screen? Then I will try it on mine to see if it can get the exact thing.
Of course. So I am in, you see, I'm already in the data folder. So if I go back up, if I show you my current folder. So here's the folders in here. So I've got the data folder here. So I would type patient underscore data equals read matrix, open and close my parentheses, and then I'm putting it in a string. So I'd say data, because we're going to look in the data folder, look for inflammation01.csv. And then I can put the semicolon in to terminate the output, so it doesn't just print everything to the screen, and then hit enter.
Okay. Okay. Why did you say data/inflammation?
So this is saying look in the data folder. So data, and then the slash is a separator. So the slash just says look inside the data folder for this file.
And then the semicolon at the end.
And then the semicolon stops it printing everything to the screen.
Yes, it's just keeping it silent.
Yeah, exactly.
Bringing it in.
Yeah, so if I do the same thing without the semicolon, it's going to print out that whole array, and it's going to make everything messy. But it does exactly the same thing. It's still going to save it as patient data. Is that all okay?
I'm trying to get it, but saying undefined. So
okay. So are you in the data folder already? So where do you have your information CSV? So if you look in my data folder, if I go into it, you can see I've got all my files.
So I'm trying to go, where is my file? So I put it in desktop, in a folder, and cancel. How can I bring it as the first time?
So if you click this, this button here to the left-hand side of the thing, then that's you can then select wherever your data is. So using your browser, I'm on Mac, but if you're on Windows, it will have something similar.
I thought I downloaded the CSV, but now I cannot see it. So maybe I should try again.
Yeah, so I just extracted mine into this folder here. So I had my zip file.
So the folder is CSV or a bigger folder?
So the folder is data. So the folder is did you download this MATLAB novice information.zip file?
I am trying to find. I thought I downloaded the CSV file, but then it's not showing again.
So so what I would do if I was you is go back to.
So I am where you are.
Yeah.
Okay. And then.
So if you go to Setup under Schedule.
Setup. Programming with Math.
If anyone else hasn't downloaded this zip or hasn't got that read matrix file working as well, it'd be good to follow along with this as well. And then it's this zip file here, download MATLAB novice information.zip.
And okay, so now I downloaded it.
So now you need to
just extract it.
Extract it, yeah. And then inside it, it should have a data folder. You got that working?
I think so. Yeah, I got it work. So I extracted it. Okay.
Yeah.
And then I just need to press the button that you said.
Yeah.
The side button, so I can have it on the side.
Yeah, exactly. And then you should be able to use this exact command and it should work. So Mehdi's asking, what's the read matrix function file format? So again, if we go to help read matrix, it's going to give us some options. So we have a look through the help. We can see what it says. So files can do some of this. So we know we could do it with a path. It should say something about types of files it can read somewhere. It doesn't say. So what we can always do with MATLAB is just go to a web browser and we can just say file formats read matrix MATLAB. And there we go. So read matrix can determine the file format. So we can do .text files, DAT files, CSVs, or a bunch of Excel files or different spreadsheet files. So the online MATLAB help files are really, really helpful and cover all the stuff that you get in the help function, but they also give lots of nice examples get rid of all these cookie warnings. It tells you things like that, like the different types. So if I scroll down, it tells you what the file types are that it can load and things like that. So first port of call is always the help function. If you can't find what you want on the help function, go to Google and go to the MathWorks website, and you can get all the things there. Cool. So,
Amarig, when I got the data, it gave me every file individually.
Yes.
I think on yours it shows data as a folder, but in mine
So if I go into data, then it should have every file individually. So then I can do the read matrix command, and I just delete that data bit.
Yeah.
And that will work.
Okay, I see. That's maybe why it's saying. Let me check. It's saying read matrix is not defined.
Are you using parentheses?
I'm exactly using the same way you're using.
What if you type help space read matrix? What does it say?
Space read matrix. It says use the help browse search field to search the documentation, or type help for help command options such as help for methods.
If you type who, does it say read matrix in there?
If I type what?
Who. So if you do who.
Okay, let me see. It says your variables are and var name 1, and it keeps saying answer elements.
Is any of them read matrix?
No, it doesn't show like yours.
Okay. No, it wouldn't show the same as mine. But what version of MATLAB are you using?
18B, I think. 18A, sorry. 18A.
18A. Read matrix. 18A. So what I'm doing now is I'm just looking on the MathWorks website just to see what versions they're on. It's introduced in 2019A, that's why. So you're going to need to use the command read CSV MATLAB. Read file MATLAB 2018A. Okay, so if you go, do you have a button that looks like import data at the top?
Yeah.
So if you press that import data button,
okay,
and then choose your file, click open.
So I open it, it shows me all the CSV files.
Yeah.
Okay.
And then so pick one of them and then click import selection. Or
should I just pick the whole table, the first one?
Just the first one, yeah.
No, you're picking numeric matrix. Should I change it to the whole table?
No. So do import data, choose your thing. From output type, you want to click numeric matrix.
Numeric matrix, okay.
Mehdi's given a, hang on, is that? Mehdi's given a new function that might be easier. Yeah, there we go. So you can use this thing that Mehdi's put in chat, which is called import data, instead of read matrix.
Import data, okay.
This is the slight problem with MATLAB is that some things don't exist in previous forms. Yeah, so that one should work. Thanks, Mehdi. Cool. So what I think we need to do is kind of carry on. So try and get that to work, Sarah, and you can always send a message to Trish in the chat and she'll help work it through with you as we go.
Can she take me to the
breakout room?
Breakout room? Yes,
yeah,
I can show her. Please
assign you to the breakout room now. Let me just do that. Yeah, so you should be able to join the breakout room now.
Let's see.
Okay, cool. So we're going to move on then, and we're going to move on to plotting data. So obviously, a big part of working with any sort of data is plotting the data. is visualizing. We can have big tables of numbers. That's not great. That's not great for anyone to understand. But if we can plot a nice picture that helps us see what's going on, then that's going to be great. So we're going to try and convert these big arrays of data that we've already looked into simpler graphs that help us understand and process. So that's what we're going to be doing now. So I'm just going to clear my window. So I'm going to use the CLC command to just clear my command window so we can see nice and neatly what's going on. And I'm going to I'm going to leave my command history there so you can see that.
Sorry, can you enable all of us to share screen? We're not able to share screen.
Yes. Yeah. How do I do that?
We do, yeah.
Yeah, hang on. 1 sec, I'll stop sharing. Okay, you should be able to now.
Okay, thank you.
No worries. Cool. So can everyone see my screen again? It's all looking good. Yeah, brilliant. So we have our patient data 01 matrix, and we want to be able to work with this to analyze it. We want to do some plotting. So maybe something we want to do is get some information out of this. We want to say what's the average inflammation. So this is inflammation data. We've got lots of patients, we've got lots of days, and we want to know what's the average over everything. So we can say what's the mean. So mean's a MATLAB function, so we use parentheses. We can use our patient data 01, and we can turn it into one column vector like you just found out with that little test. And then that's just going to give us a number that says this is what our mean of our patient data is. So the reason that we've put this in is because mean works over a single dimension. If we did it without the colon operator, we'd get the mean of every single column individually, whereas we wanted to know what was the mean of the entire data set. And again, if we want to know details about what mean does, how mean works, we can use a help command. We can type help mean, and that's going to show us how it does and how to use it. And there's lots of other things we can get. It doesn't just have to be the mean. So we can get some nice output, and we can display the maximum inflammation using the display command. We can display using the max function, patient data 01, and use the colon command. That gives us 20. We could say, well, what's the minimum inflammation? Display min, so the min command, again, it's an argument, so these take parentheses, patient data 01, that's 0. Oh, we could look at some other kind of statistical measures. So what's the standard deviation? Display standard patient data 01. That's our standard deviation. So we can get lots of individual statistical measures the same way that you'd normally ask and interrogate your data. Obviously, this is numeric data, so we're asking max and min and standard and things. But if you were doing strings, you could do searches, or you could do lots of things on your data and try and work out what's going on. But often, maybe we don't want to know, just what's the maximum of our whole data set. We want to split it up into something more sensible based on what we're looking at. So this patient data array, if you remember the size of it, patient data 01, it has 60 rows and 40 columns. And in the data, it says that each row is an individual patient and each column is their inflammation marker on a given day. So maybe we want to just extract the first patient from this set. So patient 1, and that's just going to be the first row of our patient data. So remember, we can say 1 for the first row, not 0 like in some other programming languages. And we can say take every single column using the colon array, and that's going to give us our inflammation markers for patient 1. And remember this, we're using this example of inflammation and patient data, but it can be anything. This is just a toy. This is just any matrix these commands work on. It doesn't matter what the data is. And then we can say, well, what's the maximum of patient 1's inflammation? Well, that's 18, whatever 18 means. But we don't actually have to do that. We don't have to extract it into its own matrix just to use the max command. we could have just said, well, what's the max of patient data 01, and just taken directly that row, plugged it into the max command, plugged it into the display command to get 18, get the same result out. So you can always chain these commands together. You don't have to save them as new variables in order to use them. So the way the max or the mean or the standard deviation commands work is that they work either, as we've shown, over all columns, or they work over all rows. And we can use different arguments in their function to do this. So if you do help mean, so you see mean, average or mean value, S equals mean X is the mean value of the elements in X. That's good. If X is a vector, that's what it does. But for matrices, it does the mean value of each column. And for multi-dimensional arrays, it's the mean value of elements along the first array dimension. We could do mean X and then use a second argument where we say a string of all. That does the mean of all elements. So that would be the same as using our colon command. Or we could say we want to go specifically along a different dimension. So instead of going along every row, we could want to go along every column. We could move mean X and then use 2 to say we want to go along every column. So maybe if we want to find the mean of the patients for each patient, so remember each patient is a row, so we want to say for a given patient, what's the mean value over every single day, and we could do mean patient data, and we've called it patient data 01, and then comma 2, and then that would give us a row vector. So each patient here, this is their mean value for every day that we've seen them. And again, we can check the size of this. So the size of this thing that we've done here, you see it's 60 by 1. So we've got 60 patients. That makes sense. Each patient's got a variable, and we've got 1 now instead of 40. So whereas we had 40 entries, we've now taken the mean of these 40 entries and distilled that down into a 1. So what if we want to plot through what we've got here? So we've got our patient data matrix. If we show that on the screen again, I mean, it's quite hard to see and understand what's going on here, right? It's just a load of numbers. We can't really pick out any columns. And as you get bigger and bigger data sets, this is going to get harder and harder and harder. So we're going to need to visualize it in some way. So what we can do is we can use the image sc command to kind of visualize what's going on. So what does this command do? Let's use help. So image sc, so image scaled, display an image with some scaled colors. So it scales your colors based on these values. So 0 is going to be one color, and then whatever your maximum is going to be another color, and then everything in between is going to scale what we're seeing. So usage, it says it's the same as image, so that's not very helpful. We're going to have to do help image and have a look at this. And this says image C, or image C displays the data in array C as an image. So image sc, and then we want to look at our patient data 01, and we hit enter, and that's going to plot our image. So you see here, the way an image plots, it plots from the top left corner, just like on an array. We have our 60 rows, so each one of these rows in our image represents a patient, and we have our 40 columns, so each column in here represents a measurement. And we see we've got different colors, so the bright yellows will be the maximum, and the dark blues will be the minimum. And then what we can do, if I put this over here, I'm just going to extend my screen share. Oh, no, that's the wrong thing. If I extend that share, can you see the image as well? Okay, if I don't do that, you should be able to see the figure as well as my command window. And if we extend that, we can now do some labeling, so this is more helpful. So we can use the title command to say this is our daily measurement of inflammation. You see we've got a title now that's appeared up here on top of our figure. Our X label, so our X-axis is day of trial. and our y-axis is patient number. And we can see what's going on here. And we can even use the color bar with American spelling, because it's an American program. We can use the color bar thing to show what these different colors mean. So we're starting at blue at 0. So these dark blue blocks are where the information marker is 0. We're going up to bright yellow, which is where the color is. But what if we didn't want to show this? What if we wanted to show something different? Like maybe we didn't want to just see the daily measurement. Maybe we wanted to see what the mean of the data was. So the average daily information across all patients. We wanted to see if there's something changing across all patients. So we can plot, and the plot command just takes an argument. We can say mean of our patient data. We want to look at the mean of every day, not the mean of every patient. So each patient is on the first column. Welcome back to Trish. We're waiting for Sam to rejoin. Sam seems to have left. I wonder if I always quit out a Zoom call when I leave breakout room as well. So I'm going to presume we'll be coming back in a second. Yeah, here we go, back in the waiting room. Welcome back, Salem. Just to catch you up on what we're doing. So we're doing a bit of plotting, a bit of showing the data. So we have our patient data that we've now loaded in, and we're just using this plot command to try and visualize what's going on. So the way that our data is set up, just as a recap. So if we do our size command, size patient data 01, it's got 60 rows and 40 columns. Each row is an individual patient, and each column is a day. So the data is inflammation markers or amount of inflammation for 60 patients over 40 days. And maybe what we're interested in is plotting the mean of this data over every single day. So what's the average inflammation in all our patients per day? So mean of patient data 01. We want to go over the first dimension, which is our rows, so averaging over all our patients, and that's what we want to plot. I'll give that a second, and it's just going to plot here. You see, this is going to plot, and then it's obviously good practice to always label our figures so that when we come back to them, we know what they are. So again, we can use the title command. So this is going to be daily average inflammation. Remember, it's a string, so title is a MATLAB function. So we can use a help command if we don't know how it works, but it just takes one argument and it's a string. We're going to label our x-axis, which is the day of the trial. And we're going to label our y-axis, which is the amount of inflammation. And that's what we've got here. Yeah, I've seen your message, Trish, that's fine. It's not letting me message you because it's telling me you're not in the meeting, but I can see that you're in the meeting. So I'm presuming you can hear me. So what we've done here is we've calculated the mean across every patient, and that's given us one value for each day, and then we've just plotted this along the x-axis. And we can do the same for any measure we want of patient data. If we delete that, we can plot the maximum patient data 01 over the first dimension, and that's going to give us something that looks like that. But that's probably meaning that we've done something wrong. So let's have a look at the max command, because what we were expecting to see is just one maximum value, and we've got loads of lines here all going crazy. So let's have a look at the max documentation. And you see that max, if we do just two commands, x, y, it's an array with the largest elements from x or y. So it's gone a bit weird. What we meant to do was max x and then across the right dimension. So we meant to do max patient data 01 and then just put a blank argument in here and then look over the first dimension. And that looks a lot more sensible. And again, we can give it a title, maximum inflammation per day, Y label, inflammation again, and X label, day of trial again. So remember, if we're ever unsure, like with what we just did then, we got something that didn't look right, it's always good to sense check. It's always good to use the help function to just double check we're using anything correctly. And again, we could do the same, but we could do the minimum. So we could plot the minimum amount of information per day. And we're gonna guess that minimum function works in a similar way to the maximum function. And in fact here, you can see it's giving me a suggestion of what I'd want to do. So min A, we probably want to ignore this because we're just thinking about what's the minimum over A and then the dimension. So we want to do every day. And then that's going to plot that. And we can give it a title, minimum inflammation per day, and give it a Y label of inflammation and an X label of day of trial. So that's just different ways we can plot different sorts of information and what's going on. So, so we're going to come to some questions. So first question is, when we plot just one of these variables using the plot command, so as we've already done, just plot Y, or we've done plot like the minimum patient data 01. What do the X values represent? So what's going along here? So obviously we've said these are the day of trials, but what is it actually plotting? Because we haven't told it to plot anything along the X, we've just told it to plot something along the Y. Why are the vertical lines on the plot of minimum information? So the vertical lines here coming up here, why are they not perfectly vertical? Why are they all going at an angle? And then can you create a plot showing the standard deviation of the data across for each day across all patients? And then there's a hint here about searching help for standard deviation. Remember, we've already looked at the standard function as well, so that might give you something to look at. So have a think about those, see if you can match the solutions, drop any questions you have in the chat. I'll give you a few minutes to have a think through those and have a play with your MATLAB and see how you get along. The recording will get sent through by Debbie, Kieran. I don't think the recording will be available before the end of the day today. So I don't think you'll be able to work it through. If you drop me an email, I can tell you where we got up to on the documentation. You can work it through like that, if that helps. My email, let me just put it in the chat as well, just in case people don't have it. Okay, how are we getting on with the solutions? Has anyone run into any problems? Okay, no problems. Has everyone finished the exercises?
Anything I type, it says undefined function or variable for patient underscore data.
Okay, so if you loaded in the
File, which I did, yeah.
So what did you load it in? What did you call it?
So we called it patient underscore data underscore 01.
Yeah.
Import data.
Yeah. So where they've got patient data here, you
Yeah.
probably want to write patient underscore data underscore 01.
01. All right.
Yeah.
Works. Thank you very much.
Brilliant. No worries. Cool. I'll give it 1 more minute and then I'll talk through these solutions. Yeah, so Trish is highlighting a really good point, which is good because this is what we talked about while she was in the breakout room. So if the help function doesn't, if you don't understand it, or if you can't find out exactly what's going on, then putting your search term into Google with MATLAB attached, and then going to the MathWorks website, it's super helpful. So like here, this one we looked at for the read matrix command, it has all this extra information and little examples and ways to use the command. Most commands in MATLAB have different ways of using them. You can use them in the kind of basic way, or you can add options, or you can add different types of options. So the online documentation on the MathWorks website is a really good source for that. So thanks for pointing that out. Cool. Let's talk through these things then. So when we plot just one variable using the plot command, what do the x values represent? So the x values are basically just the indices of the y data. So each index that exists in y. So the first is index 1, the second is index 2, all the way to the length of our data. So it starts at 1 for our data and goes all the way across to 40. Obviously, if we wanted to specify something different, like maybe each entry is separated by 2, we'd have to specify that and do plot x, y. So why are the vertical lines in our plot of the minimum information per day not perfectly vertical? So this is because MATLAB interpolates between the points. So it knows we have a point here, we have a point here, we have a point here, and then our next point is up here. So what MATLAB does is join the two together just with a straight line there to there, and then we go across to the next one, and then the next one's higher. So it just draws straight lines between each points. We can do more complicated things to tell it to do different things, but by default, MATLAB will just do straight lines between each point that you tell it to plot. And then it says to create a plot showing the standard deviation of the data across all patients. So very similar to the way we've normally done. So we plot standard, and we use a standard command like this, and we can use the help command to find out how to use the standard deviation command. Okay, so moving on, we can do one plot. One plot's fine. Very often we want to show more than one thing at once. So we can do that in a number of ways. We can plot like we're doing here, or we can create a new figure window using the figure command. So if we type in figure, you see that's giving me figure 2. And then I could plot something on here. So I could plot, let's take the first data, the first patient. So patient data 01. And then we want the first patient. So the first row, we can plot that. And that's what that patient looks like. And then maybe I want another figure, and we'll get a figure 3 window up. And then maybe we can plot the second patient, plot patient data 01 in the second row, which is the second patient. We could do this, and we can remember how to label and title all our plots so we don't get confused. But as this kind of comes, we're going to end up with lots and lots of different figure windows. It's going to get really confusing and really messy, and we're going to kind of get lost. So we can close these down. And one thing we can do is actually just plot more than one plot on the same figure window, the same graph. And we do this using the subplot command. So subplot, and subplot has 3 arguments. So the first argument is how many rows we have. So how many rows of images we want, how many columns of images we want, and then the index of the image that we're actually looking at. So if we wanted to plot 2 in a row, we say 1 row of images, we're going to have 2 columns of images. We're going to plot something in the first one. And now you see I've got an error here. So why is that? So the first line of the error says this is the command I put in, and then there's a little arrow pointing to here. So I accidentally put in an extra close parenthesis here. So that's what the error is. It says check for mismatched delimiters. So this is a delimiter, and it's saying that I've got a closed one, I don't have an open one because I made a mistake. So I can do subplot 1, 2, 1. Don't put a second close parenthesis in this time. And you see it's created a subplot here, 1 row, but you can see there's space for 2. And in this one, we could plot the maximum of patient data over every single day, remembering how we did it before. We do Y label, this is the max, X label, this is the day. And then maybe we also want to have a look at what the minimum looks like. So we can do subplot. It's the same size, so 1 row, 2 columns, but we want to plot in the second index. And we can plot the minimum of patient data. And then we can label our X's min and X label max. So we're still using the same plot command, the same Y label, X label commands. It's just we're prefacing them with this subplot command to show us how many plots we want to do. Of course, the benefit of Zoom is that you don't have to listen to me sneeze. I get to mute myself before blowing all your ears out. So basically, we can see what's going on. But if we actually look at what's going on, we can see there's some things that are a bit weird. We have some real change in our maximum inflammations across every day. That seems a bit weird. Why would it go up and then come back down? And then our minimum's going up and down again. So maybe there's something a bit weird going on in this file. So we really want to go through and check this in more detail, but obviously we've got so many files in here. We've got, how many do we have? We have 12 different inflammation files. We need to check each one by hand. This is going to be really tedious. We'd have to go through and kind of understand what's going on, make plots for every single one, maybe do the image plot so we can see what's going on. That's going to take a lot of time. It's going to be quite hard work. So we're going to need a better way to kind of do this and do this in a sensible way that we can just run it on every single file again and again and again. I mean, this is the good thing about using a computer, right? Computers are very good at doing repeated actions again and again and again. And we can use this to our advantage. So that's what we're going to look at next. So before we move on, how's everyone feeling? Is everyone feeling okay with plotting? Are there any outstanding questions? What do we think? Or just give me a thumbs up if you're happy. So Andre's giving me a thumbs up, that's great. Thumbs up from Michael as well. Cool, I'm seeing some more thumbs up. Just give a second or two for everyone else just to check you don't have any outstanding questions. Brilliant. Okay, so we're going to go on and we're going to start talking about these things called scripts. So MATLAB, well, all we've done with MATLAB so far is kind of typing individual commands in, running them one at a time, having to type each one as we go. But maybe we would want to do exactly the same thing for lots of different data sets. Or maybe we just want to have an investigation of our data that we can come back to and rerun all the same commands again without having to type them all out, without having to remember which order we did things in. You know, this is kind of the whole point about doing quantitative analysis using something like MATLAB, is that you can do exactly the same thing again and again and again. And it's repeatable and you're going to get the same answers. But to do that, you need to have everything done in the same order. You know, if you add some stuff and you manipulate your data and then do some calculations on it, you're going to want to do everything in the same order to get the same results. So to do that, we're going to look at something called a script. So a script is just a collection of, it's essentially a file that has all these MATLAB commands in that we can just run, and it will do lots of different things in an order, and we can keep running it and we can have it saved, and it's gonna be there for as long as we want it. So the question for this section is, oh, I've just messed up my share. The question for this section is, how can we save and reuse programs? And the objective is to learn about these MATLAB scripts, which is how we do this, and how to save these plots to disk. Obviously, when we're creating plots, it's good to see them in MATLAB, but really we're going to want to use them in some sort of write-up or a paper or a report or something like that, or just to come back and look at later on. So we're going to have a look at how we do that in this section as well. So yeah, as we've already said, we kind of typed through one by one equations into the command window, and that's kind of worked well for us. And that's fine if we're just doing one or two things, but really we want something that's a bit more organized than this, that we can kind of come to. So a MATLAB script is just a file. A file in MATLAB ends with a .m for a MATLAB file. And all the script is a set of commands. It's like a command window, so it will just type in all these little things and do all these commands in the order that you set them out. So we're going to come back out of our data because we don't want to mess up our file with our data file. So we're going to come up to our enclosing folder, and we're going to create a script. So we're going to use the edit command to edit a script. And we're going to say this script is going to be called plot patient1.m. And again, just like with variable names, you want to call your script something sensible so you understand what that script is doing. Just calling it script1 or untitled1 isn't going to give us any information when we come back to it. So we're going to hit enter, and this is going to give us a warning. It's going to say that this file, plot patient1, does not exist. Do you want to create it? Well, we do want to create it because that's what we're doing. So I'm going to do that. And then you should get this editor window come up on the right-hand side. So all this editor window is just opening that file. It's just a text file. We can type in anything that we want into this file and then save it. And then we can come back to it and that will always be in there. So I'm just going to delete that. I'm just going to save. So you can either save by clicking the save button in the top left. You can use Control S to save on Windows. You can use the Apple key and S to save on Mac, or similar commands on various Linux, depending on what you're using. But remember to always save. If you put something into your script in MATLAB, you'll see this little star appear. The little star says that something is unsaved. So you always want to save as much as you can so you don't lose any of your data. So all we're going to do in this script is exactly the same thing that we've already done. So we want to load our data. We want to plot the average information per day and just have it done through this script rather than having to type into the command window. So the first thing to do is to load our data. So patient data equals read matrix. In Salem, you can use that. Is it load import data? You can use your import data command here. So read matrix, and then we use our string. Now we're not in the data folder anymore, so we're going to have to put data / inflammation01.csv. Or if your folder isn't called data, it's called something else. you can either get rid of this data / or rename it. And then you see that if I make I'm just going to make my editor whole screen so we can see it. You'll see now that I put this in, there's this big red box on the right-hand side, and I've got some squiggly lines. This tells me that something isn't right, there's an error. And if I hover over this red dot, it says warnings found. I hover over this one, it says might be missing a closing parentheses. So this is because I've opened my thing here, I haven't closed it. So if I close it there, you see the red line's going to go away, and it's giving me an orange warning, which says, if I hover over it, terminate statement with semicolon to suppress output. So just like before, I can put my semicolon in. And if we're doing lots and lots of commands, which is what you'd want to do in a script, you probably want to terminate every little command, because you don't want to have 100 commands all printing to the command window. It'll get really messy. And because I put that in, I'm just going to save. So we've got this command here. Another thing about scripts is if you just have a load of code in here, it can get really hard to read. You might forget what it does. You might not really understand what's going on when you come back to it in a year's time. You really want to make it as easy as possible. So to do that, we use things called comments. So comments are just a bit of code that MATLAB sees but doesn't do anything with. So it's just like a phrase that you can write in. You can write whatever you want, and MATLAB won't actually try and execute it. It's just there for you. So if we push this down a line using the Enter key, and we use the percentage sign, so the percentage sign just tells MATLAB everything to the right-hand side is a comment. Don't worry about it. And we can say load patient data. So this is just going to tell us that what we're trying to do is load some patient data, and that's what this command here is going to do. And then we can continue, and then the next thing we want to do is plot the average information per day. So we can put a comment in, plot average information per day. Generally, so hang on, Joe, I'll come back to your question in a second, Andre. So generally you want to put in as many comments as you like. You don't want a comment for every single line, that would get a bit excessive. But you probably want more comments than you necessarily feel that you need at the time that you're writing. So we're plotting the average information per day. We know that we're doing this right now, but when we come back to it in a week and 2 weeks and a year's time, we're going to have completely forgotten about this file. So we want to be able to understand what's going on. So Andre's saying, would it make sense to start a script with setting up the working directory as a variable and reusing it for opening different files? Yeah, so that is definitely one way to do it. So you could set up the working directory as a variable, or different parts of the working directory. So we could say data directory is equal to data, and then / say, and then we can build it up like that. It depends how complicated your data structure is. You want to keep things as simple as possible, and that can either mean not setting up an extra variable, or it can mean adding extra variables in. If you've got a big project, then having it like this could make a lot more sense. If you've got a small project, then it might just make it more clunky and harder to read. So what we want to do is generate a new figure window. So we can use that using the figure command that we've already seen. If we didn't do this command and just started typing plot, it would just try and overwrite whatever existing figure window you had open, which could be a pain. You could have already created a figure and it could just overwrite that, which could be very frustrating. So we use the figure command to generate a new figure window. We want to plot the mean of our patient data. We want to plot the mean per day. So first column is all our, sorry, each row is all our patients. So we want to average over each row. We're not using patient data row 1 because we've called our variable up here patient data. So we've got to match our variables. And then we want to title our figure so we know what it is, daily average inflammation. We want to label our axes, so our X label, day of trial, and our Y label, inflammation. And then we want to save, so either by clicking save or by doing one of the save commands. So I'm just going to double click on the title to just pull it over to the side again so you can see my command window. So before, what we would have had to do is just type in each of these one by one into the command window and kind of gone through each. What we can do now is just type in the name of our script. So our script is plot patient _1. So instead of typing each of these commands, we can just type our script name, and that's going to do every single command. It's going to give us our figure, that's the mean of the patient data. It's given us our title, our Y label, our X label. It's done everything that we did before, but now all we have to do is plot one command. So that's really useful. So MATLAB, when we type this name in here, let me just move this figure window out of the way for a while. It's looking for any file that it can find that's called plot patient _1. So MATLAB knows about files that exist in the current directory that we're in. So if we look at our current folder, it knows about the data folder, the doc folder, the results folder, the source folder. It doesn't know what's inside them, but it knows that there are those folders. And it knows about this script called plotpatient1.m, but it doesn't know about anything else other than all the built-in MATLAB functions. And the reason it knows about the built-in MATLAB functions is because it has something called a path. So the MATLAB path is basically a list of directories that it knows to search, that it knows it's interested in. So if we click on home at the top, there should be something, a thing in environment here that says set path. So we can click set path, and this says all the folders that MATLAB will search, if I just expand this, to look for different functions. So you see it's got all these MATLAB toolboxes in, all these examples, lots and lots of things. But it's also got at the top some custom ones that I've added. So these are my custom folders. So basically, whenever I type anything into the command window, like plot patient1, MATLAB will look in the current directory, but it will also look in the path. So we can use this to our advantage and create folders that have lots of files in that we can then add, and we can add to the path using the add path thing. So if we want to add everything in the data directory to the path, we could do add path data, and that's going to add the data directory into the path. You want to be careful with the path because if you have two scripts that are called the same thing in different places and they're both on the path, then MATLAB can get really confused and call the wrong file or the wrong version of a file. So you need to be really careful about that. Generally, I would try and avoid adding to the path unless you have to, unless you have a reason to do it. Say you've got a folder where you store a particular set of functions in, and you want to only keep them there. But for day-to-day, I wouldn't worry about it too much. The only thing you need to be aware of is that if we're not in the directory where our folder is, our function is, so say we're in the data directory, so if we go to current folder, we move into the data directory, and I try to run the plot patient1 script, it's going to give me an error. So plot patient1 is not found in the current folder or in the MATLAB path. And then helpfully it says that it exists in this folder here, and it tells me exactly where it is. It gives you the option to change to the current folder or add the folder to the path. We don't want to add to the path, we want to just move back to the current folder. So that's going to work like that. So we can load our data, we can create a figure window, we can plot our figure, but maybe what we also want to do is save our figure. So we don't want to have to just plot it each time. We want to actually save it so it's just there forever. So we'll give ourselves a comment. So save the figure in our results folder. Remember, we created a results folder earlier on, and we're going to save it as a PNG image. Let me just make this big again so you can see everything that I'm typing. So we can use this using the print command. And the way the print command works is it takes a file name. So we want to put it in the results folder. And we want to call this average inflammation. So this is going to create a file. It's going to print a file. It's going to call it average inflammation, and it's going to put it in the results folder. And then the way the print command works is it needs what we call a flag, which is just a short string that tells us the type of image we want it to be. And this is a PNG, so we want it as a PNG image. We can go back to editor at the top and click save. And again, if we're not sure about how the print command works, we can do help print. And this tells us all the different types. So we can use DPDF, we could use DEPS, or we could use DPNG, which is what we've used. And if we want to find out more, we can go, as Trish said, to the MathWork website and search for it there. So now if we run our plot patient 1 script again, it's still created our figure, so our figure's still here. But now if we go to our current folder, sorry, Zoom's being irritating, there we go. We go to our current folder, we can look in our results thing, and we have our PNG image. So if we right click and click open outside MATLAB, it will just open that image that we've now saved and now just have. So when we close MATLAB, that PNG image will still be there. We can still look at it without opening MATLAB. We can send it to other people. We can put it in a report. That's great. So key things to remember then. Comments are incredibly useful. Always add more comments than you think that you need. I've never come across code and thought, oh, this is way too commented. I can't read it. That's very, very rare. More often than not, someone will send you code and it takes you hours and hours to understand what it is they've done because they've not included comments, so you can't see what's going on. So always try and comment as much as possible. But the other thing is, well, what if we forget what this function does at all? Do we have to load it up, look at all the comments and see what's going on? The way we've set it up at the moment, you would, but we know about this help command that we can use on functions. Well, we can use this help command on scripts as well. So we can say help plot patient 1. And this is just saying it says load patient data. Well, that's not really what the script does, right? The script is really to load the patient data, but also plot the average information per day and then save it per script. So this isn't particularly helpful. But the way the help command works is it just looks at the top for this kind of first bunch of comments and finds the help text. So if we put something at the top, that's going to tell us what it does. So let's put a more helpful command here. So you might have noticed in all the other help commands, like print, it starts with just the name and then a little thing that tells you what to do. So we're going to start here. The convention is to usually use capital letters, but you don't have to do this. So plot patient 1, and we're going to say save plots of average inflammation to disk. So if we save that, come back to our command window and type help plot patient 1 again, it's now going to say plot patient 1. You see that's gone bold. And the reason that's gone bold is because we put it in as a capital letter right at the start. And then it tells us what our thing is. So save plots of average inflammation to disk. So now if we were trying to remember what this command does, we just do help, that tells us, and we can make this as detailed or as simple as we want. So as long as we have matching comments here, it's then going to print everything in this matching comment block. So if we use the up arrow to go to our previous command, you see it's now printing everything. So all those spaces and the load patient data bit. So we could put loads of information in here. We could put very little information in here, whatever you want. We're just going to keep that single line because I think that single line tells us enough for what we want to do. So let's try and get some more information into here. So let's say instead of saving plots of average information, let's say we're going to want to save the plots of inflammation statistics to disk. So we're not just going to want to plot one plot where we plot the mean. Let's use this subplot command to think about what we're doing and plot lots and lots of different things. So let's plot the mean, let's plot the maximum, and let's plot the minimum. So let's plot them in a row. So 1 row, 3 columns. The first plot's going to be the mean of the patient data. The second plot, subplot 1, 3, 2. We're going to use a comment to say plot the maximum inflammation per day. So we can do this using plot max patient data. And remember the slightly odd syntax for max. Well, not necessarily odd, but different. And remember to give it a good title. So title, let's just call this max. X label, day of trial. Y label, inflammation. Let's spell that correctly. Inflammation. And then we want to plot the minimum inflammation per day. So subplot, again, 1 and 3. So for our subplots, these first two commands should usually be the same. And then we want the third argument will be which index we want to plot on. We can plot the minimum patient data per day with the title of min, an X label of day of trial, and a Y label of inflammation. Again, maybe we don't want to call this average inflammation anymore. Maybe we want to call this inflammation statistics. We click save. And we can go back to our command window and we do plot patient 1, hit enter, and you see that's created our figure with the 3 figure windows in. And if you go into your results section, your results folder, you can see that that's new PNG is there with a new name. Want to be careful with this, because if we do this again and we change something but don't change the name, it's just going to overwrite our new image. So you want to be careful you're not overwriting your new data. But if you just want to plot, if we wanted to do this for 100 files, maybe you wouldn't want to actually show the MATLAB figure each time, because every time we create a new figure, you're creating a new window, things are going to get messy. And if we're just taking a script, actually, the interesting thing is that we're creating this PNG file, so we can look at it whenever we want later on. So we can do this by modifying the figure command. So when we create a new figure, we can type visible. So figure has a visible option that we can set to off. And if we click save, so now when we run this, plot patient 1, it's done everything. It just hasn't generated a figure window. So that's really helpful. That saves us getting all cluttered and getting confused. But you might notice now, if you've been coding along as I go, we've got lots and lots of different figures all open. You know, the screen might be getting quite confused with all of these. We don't want to have too many figures open all the time. It just gets a bit messy. So we can use the MATLAB close command, and just like the clear command, we can say close all, and that just closes all our figure windows and tidies everything up. Okay, so in this section, we've talked a bit about scripts. Also, I've noticed inflammation, that should be inflammation. It's not going to change anything because it's a comment, but it's always good to be correct. We've created a script. The script contains a bunch of commands that we've set. And now we can close MATLAB, open MATLAB back up. We're always going to be able to run that script as long as we know where it is, as long as we're in the right folder to be able to search it. How's everyone feeling about scripts? Everyone followed on okay? Any problems or questions about any of that? Thumbs up in the chat, so if you understand and you're all happy. Seeing 2 thumbs up. How's everyone else feeling? Any questions? Anything you want me to recap over? Okie dokie. So in the absence of any questions, we'll move on to the last half an hour. So I don't think we're going to get through the whole of this next section, but we'll start through and we'll see how we go. So this next section, I'll just bring it up here, is repeating with loops. So as we've already kind of glossed over, computers are super good at doing repetitive tasks and doing things very, very, very quickly, as long as we set them up right. So things like repeating the same operation again and again and again, millions of times. It's very difficult for us to do as people, but very easy for computers to do in a very short period of time. So this is really where computers start to come into their own. So we're going to use something called a for loop. A for loop is something that does something for a set number of times. We're going to learn how to correctly write for loops that repeat simple commands. We're going to try and understand what's happening as those loops go, and what's changing as we go along. And then we're going to use a for loop to process all of these different files. So we've got these 12 files. So far, we've only looked at looking at one file at a time. So we're going to work through and see how we get on with for loops. So I'm going to start by creating a new script. So I can either use the edit command like we did before. And we're going to say loop. We're going to call this loop demo. And remember, a script has to end with a .m. Or I could have just clicked this little plus here on my editor, but we're going to use the edit command. It tells me it does not exist. Well, that's good because we're creating a new one. So I'm just going to click yes. And we're going to start it with a help command. So capital letters with the name of the script, which is loop_demo. And this is going to be a demo script to explain loops. So loops are, as we said, a way of kind of doing things again and again and again. It's called a loop because we start at some place, we work our way down in code, and then we jump back up to where we started and keep going round and round and round. So let's take a word. I'm going to take the word lead. We're going to terminate it with a semicolon so it doesn't give me any horrible warnings. It gives me a nice green block. This is what we're always aiming for, this nice green block in the top right. Let's say we wanted to print out each letter of this word. So we can use the display command that we've already looked at. And we can say word, and we can take the first index of the word. We can display the second index of the word. We can go through, remembering to close each pair of parentheses. And then if we save this and we run our loop demo, so loop_demo in the command window, you see it's displayed each version of the word. Now this is a bad way to code. This is a bad approach for a couple of reasons. So one, it's quite irritating. We're having to type out the same thing again and again and again. We're just repeating lots of code, right? The only thing that's changing here is the number 1, 2, 3, 4. If our word wasn't 4 letters long, if it was 1,000 letters long, this would take us forever to type out all of these lines. It'd be a real pain. But if we went the other way, if we changed words to a 3-letter word, let's say tin, then we're also going to run into problems. So even though it's shorter, you think this should be easier, but if we change our word to tin and try and run our code loop demo again, we're going to get an error. So index exceeds the number of array elements 3. This says error in loop demo, so it tells us which file the error is, where the error is, line 8, and then it prints the line. So this is trying to print the 4th letter of the word, but tin only has 3 letters. So we can't run it like that. We're going to have to delete that line. We're going to have to change it for every word that we put in. So this is a real bad way of programming this because we're always going to get errors. We're always going to have to change things. It's going to be really frustrating. So there's a better approach, and that better approach is to use what we called a loop. So if we go back to our word lead, so we change tin back to lead, let's delete all of these. So we're going to use a loop. And the way a loop works, we're going to call a for loop, and it's going to for, let's call it letter, for letter equals 1 to 4. So this is going to say a letter is equal to 1, a letter equals to 2, a letter equals to 3, a letter equals to 4. It's going to be do something, and then we're going to tell it to end. So for each entry in letter, this is going to execute everything between the 4 and the end. I'm going to increase letter by 1 and then keep going round. So we can say display, each one we want to display word, letter. So it's going to take letter equal to 1, display word 1, going to get to end. It's going to say letter equals 2, display word 2, and it's going to keep going looping around like that until it reaches letter equals 4, and then it's going to end. So let's just have a look at that. So we can save it, loop_demo. and it's going to do exactly what we want. So you can see this is already fewer lines. So we've got 3 lines, whereas before we had 4, but it's also going to be much more robust and much better, as we're going to see. So generally, the way a for loop works, if I just sketch it out, is for some variable equals some collection, do something with that variable, and then end. So maybe that collection is, instead of 1 to 4, we can say 1 by 2 to 4. So it's going to be 1, and then it's going to be 3, and then it's going to go add 2, it's going to be 5, and then it won't do anything. And each time we increase a variable in our collection, we're going to do something. And the thing that we do depends on what we've got between the 4 and the end. Remember, we've always got to have our end that tells us everything that goes between here. In other programming languages, you might have parentheses, so you might say something like, you might see something like for letter equals 1 to 4, and then you have an open bracket and a closed bracket, and you do everything and do something in between here. But in MATLAB, you use an end statement to show that. So we've slightly improved it. If we do our word as tin again, then this is still going to break because we're going 1 to 4. But if we change the 3 and we run loop demo, then it's going to display tin. So we're slightly better, but we're still having to worry about changing things in our code for our different words. But we can actually do things that are better. So let's take a longer word. Let's take aluminium or aluminum. This is an American repository that we're working on. But let's cheat and use the British spelling. So it's aluminium, as we all know. And instead of going 1 to 3, because we have more letters in aluminium, we could do 1, 2, 3, 4, 5, 6, 7, 8, 9. We could either do 1 to 9, or we could use a different function in MATLAB called length. So length just says how big the word is. So for each letter from 1 to however many letters are in the word, display the word in that letter. So click save. We can run our loop demo. You see it's printed out every single one. So now this is great. This is going to work with any word we put in here. This will always work. We don't have to change any of this code. We just have to change the word that we've put in. So we're already getting something that's much more robust. It's actually fewer lines of code. We don't have to write this display line for every single letter. We don't have to keep changing it, keep worrying about what we're doing. We just set up a loop. We're telling the loop of how many times we want it to work on, and then what we want it to do for each one. So let's take a different example. Rather than just printing out each letter, maybe we want to do something that's a bit more complicated, that's a bit more useful. Let's try and solve the problem of calculating all even numbers between 1 and 10. So we want to take each even number and we want to sum it up. So let's take a total. Our total is going to be 0. We want to loop over our even numbers. So instead of looping over our letters, let's say for each even number, our even numbers are going to start at 2, depending on whether you think 0 is an even number or not. Even numbers go up by 2 each time. So we want to do 2 by 2, and we want to go up to 10. And then we don't want to display a word and a letter this time. What we want to do is we want to add to our total the sum of the even number. So we can say total equals what our previous value is plus whatever the new value of even number is. So we're going to start at 0. Even number is going to equal 2. So 0 plus 2, that's 2. So total is going to become 2. Get to end. Even number is the next one in the sequence, which will be 4. So we're going to take 2 plus 4. That's going to be 6, and that's going to run through. And then we want to give it some output. So let's use the display function and say the sum of all even numbers between 1 and 10 is, and then we want to display just what total is. We can save, loop, demo, and that's summed each of our even numbers between 1 and 10. So let's kind of slow down a little bit and have a look line by line, what's happening, what's going on, and what do we know. And when we're doing that, I'm going to take you through something called the MATLAB debugger. So a debugger in programming is exactly what it says. So you have bugs. A bug in code is a problem or an error or a mistake. Sometimes they're really easy to find. So sometimes MATLAB will give you one of these red error messages and you can look in and try and work out what's going on. Sometimes they're a little bit more subtle. Often the hardest thing to find out in a code is when you've got a code that's working and is running, but it's giving you what you know to be the wrong answer. That can be a real pain. So the way the MATLAB debugger works is we create a debug point. So you'll see in your editor, there are these little lines. If we click one of these little lines, we get a red dot. So this red dot basically says to MATLAB, when we reach this line, pause, we're going to stop, and we're going to have a think, and we're going to go through line by line. So we can run this script either by typing in loop demo to the command window or by pressing run up here. So I'm going to press run, and you'll see a couple of things different to how we normally do it. So we've now got this big K here in our command window. The K is basically saying you're in debug mode. We've kind of paused our execution, and we've got this little green arrow. So this green arrow says we're on this line. We haven't done anything yet. And you'll see a new set of things come up here. So we have continue. If we click continue, it's just going to keep running. If we have step, if we click step, it's just going to run to the next line. And if we want to quit the debug, we can just quit by clicking this big red button here. So this is where we are. And we see we've run the total equals 0 line. So if we type in the command window total, we see total's equal to 0. We've come down to line 5. So we can type even number equals 10, but that's from the previous run. So even number hasn't been set up properly yet. If we step to the next line and type in even number again, you see it's been set to 2. So the first one here is 2. Our total is still 0 because we haven't run this line yet. So if we step to the next line and type in total again, our total is now 2. So we've taken 0 plus even number, which is 2, and we've saved that back as total, as 2. If we step forward again, so clicking the step button. Now what's even number? Even number is now 4 because we've taken 2. We've increased it by 2, it's now 4. And we step again, total is now 6. So you can kind of get the feel of how the loop's working. Every time it's taking the next element that you're iterating over, and then it's doing something, in our case, adding the total to even number to get the new total. And we can keep running that through. We can click continue, and it gets to the end and tells us what our total sum is. So this process of using the debugger and kind of stepping through is really useful to understand what your code is doing, but it's also really useful to find mistakes and try and understand exactly what's going on in more complicated options. So the debugger in MATLAB is probably one of MATLAB's best features, along with its help. In a lot of other programming languages, the debuggers are nowhere near as powerful as MATLAB for a lot of reasons, but the way MATLAB works is really good. And as we kind of sneakily showed at the beginning, in the script, we still got all the variables of things after it's run. So we've still got even number as its last value, it's 10. So we can still do things with it afterwards. Okay, so we've got another task, and what we're going to do is we're going to do this task. I'm just moving the wrong screen. We're going to do this task, and then the next task, and then we're going to finish for the day and come back 9:30 on Monday. So I'll talk you through the tasks, and then I'll hang around to 12:30 for any questions or any thoughts, or if anyone wants me to go back over anything, we can do that. So the two tasks here are performing exponentiation. So this just means raising something to the power. So MATLAB uses the caret, this symbol here, which is Shift-6 on most keyboards, to perform exponentiation. So that's like saying 5 cubed, 5 to the 3. But you can also use a loop to do it. So remember, if you want to do b to the power of x, that's just b times by itself x times. So write a loop to compute b to the x when b equals 4 and x equals 5. That's the first task. And then the second task is to go back to spelling words. So you can write a loop that spells the word either aluminum, or you could do aluminium, or you could do any word that you like, but just adding one letter each time. So it displays one letter, then two letters, and three letters. And then if you complete both of those, you can look at this looping in reverse task, but we'll go through that at the start of Monday's lesson. So we'll see how you get on with these tasks first. Any questions, just check them in the chat or just start speaking and we can go through them.